Bismillahirrahmanirrahim. Assalamu alaikum. I'm Sadia Sever, and along with my group members Javeriya Kudus, Khala Tariq, and Hasina Uzair, will present that how nanotechnology is used in the fields of engineering and in various art techniques. We'll consider three basic branches of engineering, including optical engineering, electronics, and the field of construction, while Hasina Uzair will discuss various art techniques which make use of nanotechnology. Starting with what is nanotechnology. So basically, it's an interdisciplinary science, and it is devoted to designing, producing, and then using some structures, devices, or the systems which are made by manipulation of atoms and molecules at a nanoscale. Or we can say that the nanomaterials, they have one or more dimension of the order of 100 nanometers or less than that. Having said that, a question arises that why these small sized particles are of so much importance in the fields of research. The answer is that due to their very small size, there is an increase in surface to volume ratio of nanoparticles. This results in the production of very unique properties in these particles, which might include increased scope for surface modifications or enhanced mechanical strength or catalytic properties. So, all these modifications make nanoparticles of immense importance to be used in various fields of life. For example, various industries make use of nanotechnology, including the medicine industry, the cosmetics industry, the electronics industry, the energy sector, and the agricultural industry. But here I'll focus on the use of nanotechnology in the field of optical engineering. Optical engineering is basically a branch which encompasses the physical phenomena and the technologies which are associated with generation, transmission, manipulation, detection, and utilization of light. In this field, various properties of light are used to design and then operate various optical equipment. Now, optical engineering is of two types: imaging optics and non imaging optics. The imaging optics consist of those devices in which the images are formed by using light, while in non imaging optics, light is used but there is no image formation. The first example is that of microscopy, and as it is involved with the formation of various images, so it comes under the heading of imaging optics. Electron microscope is a well-known instrument in the field of microscopy, and as we can see here in the picture of a human hair strand, that it gives us black and white images of our samples. But if fluorescent nanoparticles are used in electron microscopy, it is expected that we can get multicolored images of our samples. Other than that, nanotechnology can also be used to generate nanoscale microscopes. These microscopes are more valuable because they are easier to use, cheaper, and more accessible than the ordinary microscopes. And they also give us good results as a resolution of 65 nanometer is obtained using these nanoscale microscopes. The next example is that of fiber optic devices, and as in these devices only light is used but no image is formed, so these come under the heading of non-imaging optics. Now, fiber optic devices operate over the Raman effect, which discusses the interaction of light with the matter. As light falls upon the material of the fiber optics, there are some vibrational changes which cause the atoms to re-emit the photons, having energy lower than and wavelength longer than the incident photons. So these re-emitted photons can be transmitted over larger distances. Now, if silicon nanoparticles are used to produce this Raman effect in fiber optic devices, a Raman emission intensity 100 times greater is obtained as compared to when non-resident particles are used. This is because the refractive index of the silicon nanospheres is 300 times more than other metallic nanoparticles. Now, other than the production of Raman effect, these nanoparticles can also be used as thin films or coatings over the fiber optic devices. These coatings and thin films help in the development of novel sensor technologies. For example, they can help in the detection of gases, in the detection of varying pH levels and temperature, and increasing or decreasing humidity levels in various environments.
Assalamu alaikum, I am Churia Kudus and I will discuss the applications of nanotechnology in electronics. So this basically involves the use of nanotechnology on electronic components, especially transistors, etc. So before we move further, we should know that why there is a need of nanotechnology in electronics. So we should know that there are the two main problems of microelectronics that are currently in use. First is their physical size and second is the fabrication cost. So we can overcome these problems of microelectronics by the advantages of nanotechnology. This provides us with a decrease in size and weight of the devices, decrease in the power consumption, increase in the number of transistors in electronic circuits, and thus overall increase the capabilities of these electronic devices. Interatomic interactions and quantum mechanical properties play a very significant role in the working of these devices. So first comes the processors. So nanotechnology promises more powerful computer processors by replacing traditional cheap metal oxide semiconductors by nanomaterials like nanowires, etc. Nanolithography is a technique that is used for the fabrication of the chips. All modern processor architectures like ARM Cortex are using the nanotechnology for manufacturing of microchips processors. Memory storage. So here we can see the evolution of memory storage devices, and here we see the decrease in the size and the price, while the storage capability remains the same. So basically increasing the density of memory chips can hold up to terabytes in a very small size of per square inch or even greater. So Nantoro company has developed carbon nanotube based crossbar memory called nanobar, or it's also called NRAM. So it can store up to terabytes of memory in a size of few nanometers. Displays. So we know that the quantum dots are both photo and electroactive. So using quantum dots LEDs to replace fluorescent dots used in current displays make them more flexible, thin and use less power. So the basic advantage of QD based materials or displays is their lower consumption of power, lower cost of manufacturing, longer lifetime and purer colors. Flexible electronics. So cadmium selenide nanocrystals, when deposited on plastic sheets, have been shown to form flexible electronic circuits. So it is believed that the graphene will dominate material in flexible electronics. Potential applications of these flexible electronics will be in the wearable electronic devices, compact portable devices, robotic devices and biomedical devices. Lithium-ion batteries. So one of the drawbacks of lithium-ion batteries is the degradation of silicon. So researchers at Stanford University and SLAC are developing techniques to surround silicon nanoparticles with fullerene cages through endohedral modification to prevent the degrading of silicon in the anode. Moreover, researchers at Los Alamos National Laboratory have demonstrated a catalyst made from nitrogen doped carbon nanotubes instead of platinum, which we know is expensive. So they believe that this catalyst could be used in lithium air batteries, which can store up to 10 times as much energy as lithium ion batteries. Coating. So nanotechnology has also found its use in coatings. So polymeric nanocomposites are used as hydrophobic coatings on electronics like mobile phones. So what they basically do is that these coatings increase the contact angle between the water liquid and the surface of for example mobile phones. So due to this increase in contact angle, the water forms a droplet and shed off from the surface. Moreover, nanomaterials are also used as an antimicrobial and antibacterial coatings on the mouse, keyboards, cell phones, castings, etc. So here are some under development applications of nanotechnology in electronics. So some researchers have demonstrated atomically thin indium tin oxide sheets that may make touch screens that are costless to manufacture and as well as being flexible and consumes less power. Some researchers at UC Berkeley have demonstrated a low power method to use nanomagnets as switches like transistors in electrical circuits. So what they basically do is to replace transistors in electrical circuits with nanomagnets. So their method might lead to electrical circuits with much lower power consumption than transistor based circuits. Moreover, researchers at Georgia Tech, the University of Tokyo, and Microsoft Research have developed a method to print prototype circuit boards using standard inkjet printers. So, silver nanoparticle ink was used to form the conductive lines that are needed in the circuit boards. Okay, so these are some of the companies that are the ambassadors of nanotechnology in electronics, which includes Nantro, Nanomix, Nanosys, and Quantum Dots. That's all. Thank you.
Assalamu alaikum. Bismillahirrahmanirrahim. So the first one is microscale artwork. Advancement in the photolithography and integrated circuit has led to the development of micro-engineered art. These artworks represent social trends, culture values, storytelling, self-expression, and beauty. One of the best examples of this type of artwork is semiconductor artwork. Basically, these are the microfabricated devices that are usually used in semiconductor chips. They may include the chip designer names, renderings of favorite pets, cartoon characters, and so on. These figures are showing the cartoon character, while there is a name of the designer who has made this chip and the pictures of those designers. The second, the second type of artwork is microfluidic artwork. Basically, it uses the concept of microfluidic devices. The first one picture is the sphere, which is basically providing an impression of a celestial body which can be seen through the window of a futuristic spacecraft. The second figure shows the drop of water shown by the blue and green color organized into square regions that are separated by the hydrophobic boundaries. The third type of artwork is nano artwork. Basically, the aim of nano artwork has primarily been to demonstrate new nanofabrication methods that can be used to create engaging visualizations that show the infinite capabilities of the fabrication technology. One of its type is lithographic writing of artwork, which uses focused ion beam milling as a fabrication technique for creating artwork. It involves selective ablation of materials with nanoscale accuracy using liquid metal ion beam at high primary current. These are the few examples. The first one is the map of Africa. This pattern was etched through oxidative lithography on a silicon wafer using a 10 nanometer wide tip of an atomic force microscope. Second figure shows the Statue of Liberty, while the third one shows a sand castle made from sand grains. Its second type is two-photon polymerization of artwork, which involves spatial resolution of controlled 3D photopolymerization of a UV-absorbing resin within the focus depth of near IR laser beam. This technique can be used for creating artwork at sub-diffraction limited resolution of 150 nanometer. This figure shows the image of a model that is microfabricated sculpture and named as Trust with nanoscale features. It is considered as the smallest creation of the human form ever made. It is so tiny that it can be through it can be seen. It is so tiny that it can be seen in the image of the eye of a needle. These are the few other examples. Next type is nanoparticle based artwork. It uses ink that could be printed to create visually appealing image. This is a figure showing a figure of a sun that is printed by gold nanoparticles. In order to create this image, silicon templates were modulated and then inked with a colloidal suspension. This image contained around 20,000 gold nanoparticles and was printed in 12 minutes. This work represented an example of using nanotechnology in the context of alchemy to create a story to captivate the reader attention. One of the way of developing images is to visually communicate with scientific findings. So Franklin used quantum dots in which he designed a series of vials with luminescent nanocrystals that have the ability of emitting light. Another way that can be used to create visually appealing artwork is the use of the ferrofluid. Basically, ferrofluid is a magnetizable liquid that consists of surfactant coated with iron oxide nanoparticles and suspended by Brownian motion. These carrier liquids contain minerals and silicon oils, polyethers, and synthetic hydrocarbons with addition to water. So Fabian Ornifer used this idea to create malleophory-like patterns using ferrofluid and watercolors. When watercolors were added to the ferrofluid, they were confined within the barriers of the ferrofluid. These mixtures form black channels and ponds that do not commingle due to the hydrophobicity of the ferrofluid. Thank you. That was all from our side. We hope that you liked the video.